This is a question of conservation of energy, right? This is the alpha particle is speeding along. Oh my gosh, it's a red pen land, right? It's 2 neutrons, 2 protons, right? It's speeding along, so it's got kinetic energy, right? And then here's, there's this giant nucleus. Okay, an iron nucleus sitting here with all of its positive charge, right? And it's going to get to some distance here where its kinetic energy turns into potential energy, right? Because it's going to, the closest is that it hits spot on and actually stops and then turns around and goes back the other way, right? So ultimately, when it's here, it's got a potential energy of K Q1 Q2 over R, right? And this is in that crazy complicated thing. We've solved problems like this, right? Okay, and then we're solving for the velocity, right? So 1/2 mass of the alpha, and I'll always give you that mass, 6.64 times 10 to the minus 27th kilograms. And then in this case, we don't know the velocity, right? Is K, which is 8.99 times 10 to the 9th Newton meters squared per coulomb, squared. All right. And then Q1 is maybe the alpha particle, right? And it's got 2 protons, so its charge is 2 times E. So 2 times 1.602 E minus 19, right? And that's coulombs. And then this is our Q1, and then Q2 is whatever this nucleus is. Has the Z is, of course, the proton number, right? The atomic number. And so this is going to have, in general, a charge of Z times E, right? So in this case, it's 26 times 1.602 E minus 19th coulombs, parentheses. All right, here we go. And then let's see, how close are we getting? 5.0 femtometers. All right. Let's assume that we had 3 sig figs. Evidently we don't. Times 10 to the minus 15th meters, right? Which is getting down there, right? That's, we can figure out the radius of this nucleus. It's going to be on the order of 10 to the minus 15th. So, okay, so now we want to solve for v squared. So I think I'm going to just bust out this entire right side. 8.99 times e to the 9th times 2 times 1.602. 17th times 26 times. The astute observer would realize we could just square E in the numerator. Okay, let's see, divided by 5, E minus 15. Now I've got the entire right side, and I'm going to multiply by 2 to get rid of the 1/2, and divide by 6.64, E to the minus 27. Now I've got what v squared is, and I'm going to square root it. And I get v is, let's see, 2688375.8.5. Let's see, 1, 2, 3, 4, 5, 6, 7, 2.69 times 10 to the 7th meters per second, which is what we got. There it is, right? And we could things we could look for. We could actually try to solve for what Z is. We could solve for what R is. It's always an alpha particle, though, right? Because Lord knows, we couldn't do this with a proton or something. Okay, there it is. I've never had a group of students take this assessment that have actually solved these in some previous assessment, right? Some previous. We've done these before, right?